Hello all, welcome to Codeforces round 990. We are solving problem D, move back at a cost. So in this problem, we are given array of integers a of length n, and we can perform the following operation 0 or more times. That is, in one operation, we'll choose an index I and we'll increment it by I plus 1 and then move that ai to the back of the array. That is, let us suppose we have 3519. We choose I is equal to 2, and that I is equal to 2 is 5. We will add 1 to it, that will become 6, and then 6 will move to at the last of the array, and all the rest will remain in same order. So 319 and then 6. And we have to find the lexicographically smallest array you can get by performing these operations. So lexicographically smallest means that we have to sort in the array by following this condition. That is, the removing the ordering will cost us this increment on some values, and they will be moving back at the last. So this is we have to keep in mind. We have to solve this for t test cases, and will be the length of the array, and ai can range up to 10 to the power 9. Okay, so idea here is that first is we know that one will be coming at the very front, and if because one, there's nothing less than one, so everyone will try to come in front. So let us say we have 2 1 3. I know before 2 1 should become at here, so I need to remove this. So this one value will be added to here, it will become 3, and it will become 1 3 and 3. This 2 will become 3, and we will move at the end, it will become 1 3 3, and now it is in sorted order. Next, if I come to 1 2 2 1 4, 1 is its correct position, 2 is not its correct position because there is one left over here. So in order to move this one forward, I need to add 1 to it, move it back. It will become 3, but there is one more 2 to go. So this will be adding one more, and it will go to the last. It will become 1 1 4 3 3. Okay. In next iteration, I'll have to remove 4 also. So I'll add 1 to my 4, and 4 will move at the last, and finally I will have 2 ones, 2 threes, and 1 5. Okay. So we will see this using uh, the third example is 1 2 3 6 5 4. We will see this using the logic basically that we want to achieve. What I'll do is I'll create one multiset. So in multiset, my values can be repeated, and it will be in some order, sorted order. Not possibly it's sorted order, but very first value will point to my very first smallest element in my multiset. Okay. What I'll do is, initially when I'm taking the input, I will push all the values in my multiset. A multiset will have the same values as my AI. Now I will create another answer array, and in that array I will be storing values one by one. I'll start with 1. I'll see that in my multiset, is there a value less than, that is the very first begin part, that is the beginner pointer will be pointing to the smallest value in multiset. I will check that whether the AI current value is matching that or not. If it is matching, I will simply add it to my answer vector. So initially I'll start it, I'm at 1, I will see that my begin is 1, I will add it to 1. After that, I will remove 1 from my array. Simply I can remove array also because I'm moving index wise, so in order to avoid confusion, I have removed it. Now I'm at 2. Are the m dot begin matching with 2? Yes, it is matching. So what I'll do is I will add 2 to my answer. I will remove 2 from my multiset, and I will now move to my next index. Now I'm at 3. Same, smallest value matches with the multiset. I will remove that. I will remove it from array also. I'll move to next index, and I will add it to my answer vector. Now there's a mismatch. The minimum value in my multiset is 4, but current value is 6. What I'll do is I'll I'll add the value that I currently I have, that is 6. I will add 6 plus 1, that 7, to my answer, and that 7 will be added here, and this 6 will be removed. What I did, currently I am at 6. I will add 6 plus 1 7 to my answer vector. I will add 6 plus 1 to my map. I will then remove 6 from that. Why? Because in order to satisfy this 4, it comes to its normal position. This will move at the very last. And moving this at very last will make it the 6 to 7. So now when 6 is removed in my map, I will be having 7. Whereas in my answer, I will have 7 also. Now, what I do is, I am at 5. I will see that whether my 5 matches. No, it is not. Again, there is a mismatch. What I'll do is I will add 5 plus 1, 6 to my answer and 6 to my map multiset. I will, sorry, not map, multiset. 6 will be added and it will be removed from here, and from multiset also 5 will be removed. Now I am at 4. This is also at 4. This will simply, I will add it to my answer. This will also will be added. So this is the iteration that it is done. If we see the example, the answer is 1, 2, 3, 4, 6 and 7. Here my answer is 1, 3, 7, 6, 4. This is my answer vector. I have done with the iteration. What I'll do is I will sort my answer vector. After sorting, it will become 1, 2, 3, 4, 6 and 7. I guess that is the what we required. Yes, 1, 2, 3, 6, 4. Same is what we get here. So that is all we have to do in this problem. We are assigning it to the right positions and moving it accordingly. So that is all we are doing it here. If we see that after taking the input, I'm creating a multiset. In multiset, I'm inserting all the values over there, creating an answer vector. I'm iterating through A. I'm checking that what is my first element. If the current element in array matches with the first element, I'm pushing back that element into my answer. Otherwise, I'm pushing back I plus 1 in my answer. And similarly, s dot insert, I'm adding I plus 1, that updated value from a map, and I'm removing that current pointer that I have, because it is multi-set. If we remove the I, it will remove all the occurrence of I. So we'll have to figure out the very first occurrence of I, that will return me a pointer, and I will erase that pointer only. So similar, and when all that is done, I will have an answer vector. I will sort it and I will print it out, and that will be my answer. So yeah, that is all we have to do in this problem. One question you can ask is that why this was not coming what we required. That what about this 6 and 7? They can be in any order or any way. Answer to that is, it was on me that how I am dealing with removing. That is, I came in this order. 6 was encounter first. That is why it went at the last. I have the liberty, I can move it in any order. So instead of going at 6, I could have easily removed this 5. This could have become 6, and then 6 would have been inserted, and then 7 would have inserted. So this is just addition to the map. This is not considering anything to our answer vector, because we are adding those values. It has only to consider with that only once my value will be updated and it will move to the last, and that depends on us, that how we want to sort it. We have to minimize, not minimize, we can alter any position as we want. So it is not necessary that it has gone to last. So first this was updated, now we have to solve it for 6 and 7. No, we just want to put the things in correct order, and other things will come eventually, land it up, because there is an appropriate way to that, because it does not depend, because we were iterating from left to right, we were going from one end to another end. So that is why it happened that 6 occurred after 7. We could have another way, as I told you. If we have considered 5 first, it would be 6 and 7. So yeah, that is all. And finally we are sorting it, so it does not matter that what it comes. Main was that we arrange the right elements, those are not untouched, they come in proper order. So that was the main logic. So I hope you all understand, and if you have any query, do comment it out. If you like the button, if you like the video, hit the like button and do subscribe for more daily content. Thank you.